Okay, in this lecture, we will start our discussion of normalization. So we'll first, let me pick up the pen here. So we'll start by recapping what is the goal of normalization. We informally mentioned it in our previous lesson. And then we will have a more detailed discussion of the start of the normalization process, something called the first normal form. And then we will see how one proceeds on further steps of the normalization process in a subsequent video. And along the way, we will use examples, a variety of examples. So let's first recap what is the goal of normalization. So it's really, to put it simply, normalization is simply a process of taking a table, inspect it to see if it has any deficiencies. By deficiencies, we mean the various types of anomalies that we discussed in our very first lecture. We try to see if it has any of those anomalies, and then we go through a process of taking care of those anomalies one at a time. Um, and the objective of the normalization process is to end up with relations that are so-called well-formed. Well-formed means they don't have those anomalies. So the analogy that I would present to you is a patient coming to a doctor with some illnesses. Okay, so the doctor checks out the patient and identifies, oh, this patient has such and such illnesses. And then they start treatment. They start giving a particular medicine. It takes care of some symptoms of the illness. And then the doctor says, well, it's not quite there yet. The student and the patient is not quite whole yet. Give maybe a stronger medication or some other medication, and the patient improves. Maybe it's still not there in terms of health. So the doctor says, well, the patient is not completely healed. Give some more stronger medication, or again, a different medication. At the end of this process of treatment, the doctor concludes, well, the patient is in a reasonably good form. Okay, in a reasonably healthy state of health. So that's a very similar analogy over here. We will start with a table, inspect it for anomalies, for deficiencies. Those are the anomalies, and then we will go through this normalization process. Think of the normalization process as the medication, giving the different types of medicine, and at the end of the process, we we'll again keep inspecting the relations along the way, and we end up with the patient, as in the doctor's analogy. The doctor concludes that the patient is in a reasonably good state of health, and we will also conclude that the relation is reasonably well formed. Well formed is just a fancy way of saying it doesn't have too many deficiencies. Okay. Now, as with medications, you can keep doing stronger and stronger medications. There are many different normal forms. Okay, so we'll start off with the first normal form. That's sort of the starting point, the baseline, and that's what the focus will be for this video. But there are higher, so-called higher normal forms: second normal form, third normal form, fourth normal form. There's another one called Boyce normal form, BCNF. So think of these progressively higher normal forms as stronger or different medication to keep to address the deficiencies, trying to get rid of more and more deficiencies. Okay. So you're giving stronger and stronger medication. Now you can keep going on and on, but for most business applications, going up to what is called the third normal form is pretty much all you need. You don't need to go to higher normal form. So I hope you have a sense of what the normalization process intends to do, and what is its end result, and why are we doing normalization. Okay. So we just said that in the normalization process, you start with the table and then look for deficiencies. If it does it have any deficiencies in it, and then we start improving by applying medication. This is the normalization process. So the first step is putting a table in first normal form. In order for a table to be in first normal form, that's the starting point of the normalization process, three things must happen. The table must be a relational table. If you again go back to our second lecture, or the one previous to the video previous to this one, we had made the statement that all relations are tables, but all tables are not relations. So there are certain properties that a table must have in order to be a relation, like two columns cannot have the same name, The order of rows is irrelevant, the order of columns is irrelevant. So there are all those little properties, okay? So a table must be a relational table, but the two issues that we will concentrate on here for this lecture is that we must remove what are called repeating groups. We'll see what they are. Once we see an example, it'll be pretty evident why repeating groups arise in practice. So we will identify repeating groups and we have to remove them in order to get a table to be in first normal form. Okay, and then once that repeating groups are removed, we have to identify a primary key for each table. Okay, so, because remember we said that in a relation must have a primary key. That was one of the integrity rules that we had mentioned early on in the course when we discussed the relational model. So for in this particular video, our focus will be on what are repeating groups, how do we remove them, and then after doing so, how do I identify the primary key of each table. Once that's done, we will have a table in first normal form, and that is our starting point for the cleanup process for getting rid of the deficiencies and the anomalies. Okay, so let's first try and understand what are repeating groups. Okay? How do they arise in practice, and how are they represented in the tables themselves? So a repeating group is typically an attribute that can have multiple values. So here is an example. So we have an employee table. So we have the employee number, that's a property of the employee. The first name of the employee, that's another attribute of the employee. We have the last name, which is also another attribute of the employee. And if you look at these last two columns, this is really one attribute. We want the telephone number for the employee. But it just so happens that this property, telephone number of the employee, is multi-value. Means it can take multiple values. The employee could have a home phone number, an office phone number, a mobile phone number. So it could have multiple phone numbers. So this attribute, if you think of as the telephone for the employee, this attribute is multi-value. Okay, so that's the repeating group. It's an attribute that can have multiple values, that can repeat itself in terms of values. Okay. So here for this particular example, we have Michael Smith who has two telephones, Maggie Barnes who has two telephones, but Troy Zane has one telephone, and so forth. Okay. Now here are some problems with repeating groups. I do not know offhand how many times the value might repeat. Okay, so for instance, in the case of telephones, I suppose it would be highly unusual for somebody to have 5 telephone numbers, but I suppose they could. But think of if this attribute was a children's name. So you have the employee, and you have this particular attribute is the name of a dependent. Okay, so then it's very difficult to tell how many dependents an employee might have. They might have none. They might have 1, 2, 3, 4, 5. All. So it is difficult to tell ahead of time what the number of repetitions might be in a repeating group. And if we represent repeating groups the way we have with these multiple columns, then we will have to have many individual columns for each instance of the repeating group, and there will be a lot of null values, isn't it? Not everybody will have multiple phones, not everybody will have 5 or 6 dependents, so there'll be a lot of wasted space and null value. Also, searching for values it becomes difficult if you store the repeating groups in multiple columns like this, okay? Because you'd have to go through all the different columns. If I'm searching for a particular phone number, I can't limit my attention to just one column. Since there could be multiple columns, I have to do my search across multiple columns. It just complicates the search process. So repeating groups are a bit of a nuisance when it comes to tables and relations, and we need to be able to address them, to take care of them, okay? So let's see how one can take care of repeating groups. So if we continue with our example of the employee with the phone numbers, so this is the left hand. The table that you see on the left hand side was the original representation of the employees, and we had one separate column for each telephone that an employee has. Now look at what we have done on the right hand side. We have one column, only one column called the telephone. We don't have two columns just because there are one employee has two telephone numbers. We only have one column called telephone. So how do I address the issue that the situation that Michael Smith has two telephone numbers? So all I do is I create a second record for Michael Smith, which has the different phone number. Okay, so look at what we've had. So in this transformed table, we have the first record being 101 Michael Smith and this phone number 555-222-3456. That's the first record. And then we create a second record for the second phone number by repeating all the details of this employee. So again, I say 101 Michael Smith and the second phone number. All right. So now there are two records for Michael Smith. By the same logic, there will be one record for Zane Troy. Okay. There will be two records for Maggie Barnes because Maggie has two telephone numbers and so forth. Okay. Now, how we have solved one problem, but you will quickly see there we have created another. Now we have all the telephone numbers are in one column. Okay, so if I want to search for any phone number, all I have to do is focus my attention on the telephone column. But I think you can guess what the side problem that I have introduced. I can no longer identify any row by the employee number. So think back to the relational model. Every relation, every table must have a primary key, must have an identifying attribute. Okay, so in the table on the left hand side, if I want to identify an employee, I just specify the employee number, and I know, and I can identify the row if I want to identify any particular row in the table. But now on the right hand side, I have fixed the repeating group problem, but in the process, I can no longer identify any one row by just the employee number. Okay, so I've introduced that complication in the process. So here's a slightly more involved example of repeating groups. So on the left-hand side, again, we have the, we have the employee records. This time, we are showing a situation where an employee can have multiple phone numbers and have multiple email addresses. Okay, so really, the attribute that we're thinking about is telephone over here, and the attribute that I'm thinking about is email over here for these two columns. It just so happens that this attribute called telephone is multi-value. All that means is that for any one employee, that attribute could have multiple values. Okay, and remember in the relational model we said that every value in a cell must be atomic in a relation, right? So similarly, if you think of the attribute called email, it's a multi-valued attribute. All it means is if I pick any one employee, that particular attribute called email could have multiple values. Now, in this example, we are showing a maximum of 2 telephones for any employee, or maximum of 2 emails for an employee. But clearly, that's not a general truth. You could have an employee with 3 telephone numbers. You could have an employee with 3 email addresses, and so forth. So this is another example of a repeating group. But the repeating group, there are 2 repeating groups, one for telephone, one for email. So the approach to fixing that problem, to removing repeating groups, is the same as before. The concept is the same, namely, add new rows to take care of the repetition. That's what we did over here. In the case of the telephone, we just introduced one more row for the second telephone each time an employee has a second telephone. So we do the similar thing over here, except that now we need 2 separate columns, one for each repeating group. So the first repeating group is telephone. The attribute telephone can have multiple values. The attribute email can have multiple values. So there are 2 repeating groups here, one for telephone, one for email. So I create 2 separate columns for it, and then I repeat the rows. I add additional rows, okay, as needed to take care of the repeated values. So let's see how one would do that. So for the first employee, Michael Smith has 1 email address, but 2 telephone numbers. Okay. So how does that translate to the new table? So so notice I have to fill in all the values here. I cannot keep null values here. So I have The first three columns are the employee number and first and last name for Michael Smith. Then I pick the first telephone and I pick the email address for Michael Smith and I fill those in. So that's how I construct the first row for Michael Smith. Now, Michael Smith has a second telephone number, so I create a second row in this new table. So again, I have the employee number, first name, last name. This time I put the second telephone number and I repeat the old email address. Okay, so basically the approach is every time there's a repetition in the original table, create a new record in the new table. Okay, so once the translation is done, let's pick another example here. Tanisha Johnson has one telephone but two email addresses. So I think you can guess how this would translate. You would have two records, one for the first email address, one for the second email address, and in both those records, the phone number would be the same. So let's look at Tanisha Johnson here. So the first record for Tanisha Johnson says 106, Tanisha Johnson, and then the phone number is 555-902-3489. That's what we have over here. And the first email address, that's the first email address, which shows up here. And now there's a repetition of the email address for Tanisha Johnson. So I just create a new record with the employee number, first name, last name, that one telephone number, but now the second email address. That's what we have over here. So I hope you got a sense of, it's a fairly easy process, so easy transition. So every time there's a repetition for the repeated group, repeated value, just create a new record. Okay, and the record has to be filled out in the manner that we have just discussed over here. All right. So here is a third example of a repeating group. So in the previous example, we had two different attributes, each of which could have repeating groups. We had the attribute telephone, which could have a repeating group. Email as an attribute could have repeating groups. So there are two different attributes, each of which could have repeating groups. Okay. Now, in this third example, it's not really an attribute that is repeating, but it's, what should I say, multiple attributes that are repeating. So here you have a situation where an employee could be assigned to multiple projects. Okay. Now, there is no reason to think why an employee should be assigned to only two projects at most. It could be 3, 4, 5, what have you. If an employee could be assigned to 5 projects, then you would have 5 repetitions for the project. It's just that the difference between this example and the previous one is that the project is not one attribute. The project consists of 3 attributes. So there's a project number, project name, and the project hours. Okay, so these 3 attributes constitute a project. And if an employee can be assigned to multiple projects, each time an employee is assigned to another project, this set of 3 attributes will repeat. Okay, so for example, Michael Smith is assigned to 2 projects, projects P15 and project P64, and we have these different attributes of the project, the name of the project and the project hour. So this is another type of repeating group that can, right? So how would one take care of this repeating group? The approach is the same, meaning as the previous 2 examples, meaning wherever there's a repeated value, create a new record with the repeated value. All right, so we will create a table. Now let's look at the columns in the table. We have employee number, first name, last name, as before. Those are the properties of the employee. And now we only keep the 3 attributes of project. So we have project number, project name, and project hours. So now when an employee is assigned to 2 projects, I just create 2 separate records, one for each project. Okay, so this first record over here is Michael Smith, the 3 properties of Michael Smith, followed by the 3 properties of the first project, P15 WorldComp 23, P15 WorldComp 23. Now this repeated value of the project, P64 High Fashion 16, that becomes a new row. So again, I have all the properties of Michael Smith, that is the employee number, first name, last name, and then I add the properties of the second project. So every time there's a repetition, create a new row. It's the same approach that we had previously. Okay. So now for Zane Troy, there will only be one row because Zane Troy is assigned to only one project. So here you see Zane Troy. Tanisha Johnson has been assigned to only one project, so there's only one row that corresponds to Tanisha Johnson. However, Kim Rai is assigned to two projects, P23 and P15, so there will be one row for each project. Okay, repeat that. So here we have 102 Kim Rai, the Rai Kim rather, and then here's the project P23 Acme Inc. and 18 hours. And then the second project to which Rai Kim is assigned becomes a new row. So here's a new row. So do you see that the general approach to taking care of repeating groups is to create a new table that contains the attribute or attributes that represent the repeating group. Every time there is a repeated value, just create a new row, a new record for the repeated value. That's the general approach to taking care of repeating groups. So that's one of the things that has to be done. Repeating groups arise in practice in table because real world data can have situations where repeating groups arise. We already saw examples of it. Let's say dependence for an employee is an example of a repeating group. So repeating groups is not an artificially created artifact. It can arise in practice. So we need to know how to take care of those in that situation in order to start a normalization process. So coming back to our starting the normalization process, we need to set up the relation to be in first normal form. So one of the things that needs to be done is to remove repeating groups. If I have a table and it has repeating groups, I must first get rid of repeating groups in order to put it in first normal form. Okay, and we just went through a discussion of how one handles repeating groups and represents them to in a way that the repeating groups are removed from the new structure. Okay, and then of course the table must be a relational table, so all those requirements of column names being distinct and so forth have to apply. Now we'll look at this last bit over here, that once you have removed the repeating groups, take the resulting table, and in that table you must be able to identify the primary key. Every relation must have a primary key, right? So let's see how one goes about doing that. Here's the third example. Okay, so the last step there is I need to be able to identify the primary key of each table once those repeating groups have been removed. So just to recap something about primary keys that we discussed early on. Primary keys cannot be null. Okay, because a primary key identifies every row in the table, it cannot have a null value. And these are additional features of a primary key that are good to have. Primary keys should not pose privacy or security or legal concerns. We had discussions where social security number is unique, but it can have privacy concerns. There may be reasons to keep it secret, again, not to release it. Okay, primary key values should not change. So even if the email address for an individual is unique, email addresses keep changing all the time. Okay, so it's not a good idea. It's not helpful to use email address as a primary key because then its identifier keeps changing all the time. It should be verifiable for accuracy, and we prefer fixed with primary keys. Like even if a name could be unique, I don't want to use a name because names typically can have variable length. We typically want fixed with primary keys. Things like student ID numbers, license numbers, social security numbers, typically they're formatted to have a fixed bit. So this is just a recap of the properties that primary keys should have. And also remember the purpose of a primary key. Why is a primary key there for a table at all? A primary key helps you identify every row uniquely. If I specify the primary key of a table, I can identify any one row in the table. That's the purpose of having the primary key. So with this information, let's proceed and see, take each of these tables that were generated after removing of the repeating groups, and let's see what the primary keys are. So let's take the first table that was generated as a result of removing the repeating groups for telephones. If you recall, this was the example where each employee could have multiple telephones. So we had Michael Smith, who had two telephone numbers. That was the repeating group. And the way we fixed it is by creating two records, one for each telephone that Michael Smith has. So I got rid of repeating groups. Now I have all my telephones in one column. But what is the problem that I have created in the process? The problem that I have created in the process is that I can no longer identify any row uniquely with just the employee number. In the previous, in the version of this table where you had the repeating groups, you could identify any row uniquely just with the employee number. But now I can't. So what do I need to know in order to uniquely identify any row in the table? I need to know both the employee number and the telephone number. If I specify to you the employee number and the telephone number, then I can uniquely identify any row in the table. So what has happened? I have fixed the repeating group problem, but in the process, I have complicated the primary key. I now have a composite primary key. You can see these two columns are identified. Now, any table can only have one primary key, so don't interpret this particular these two underlines that, oh, there are two separate primary keys for this table. There's only one primary key. If you see two columns identified, it means the primary key is composite. It consists of those two columns together. Okay, so a sort of an undesirable side effect of removing the repeating group is that I've ended up with a composite primary key. So here we have drawn the original table and the resulting table. So in this table on the right hand side, I have no longer have repeating groups. So now if I have an employee, if suddenly employee number 101 gets a third telephone, in the previous structure, I would have had to alter the structure of the table, create another column, etc., etc. And all the employees who have only one telephone, we are wasting space storing that extra information. But now, once I have removed the repeating group, if Michael Smith happens to get a new telephone number, all I have to do is insert a new record into this particular table. Okay. So we have cleaned up the structure to take care of repeating groups, because I don't know how many times the repetitions might occur. But in the process, I have complicated the primary key. The primary key here on the left-hand side was employee number. I could identify any row uniquely with just the employee number. I can't do that anymore. I need to know both the employee number and the telephone number. I have a composite primary key. Okay? And typically, when you have repeating groups, and then you take care of repeating groups in this manner, the price you pay for it is in terms of redundancy. That is, you would have multiple rows with the same information in them, and you will end up with a composite primary key. That's typically what happens. Let's look at example number 2, where we have two attributes of the employee, each of which could be repeating groups. So telephone was a repeating group because an employee could have multiple telephones. Email address was also a repeating group, meaning an employee could have multiple email addresses. And the way we took care of that same approach, anytime there's repetition, add a new record in the table. Okay. But now you can see if you just go through the table, if I give you just the employee number, now in the original table that we have for this example, I could identify any row just by knowing the employee number. Okay, I can't do that anymore. If I tell you employee 103, here are 4 records that could match employee number. I'm not uniquely identifying any one row. If I know just the telephone number, I'm not able to uniquely identify any row, because here are 2 rows with the same telephone number. Okay. Similarly, email address by itself cannot uniquely identify any row. All right, just because of the repeated value. What do I need to know in order to uniquely identify a row in this table? I need to know the employee number, as well as the telephone number, as well as the email address. Do you see the repeating groups, the column names show up in the composite key? So I have a composite key, whereas Previously, I was able to identify every row by just the employee number. Now, as a result of getting rid of the repeated groups, I now have a composite primary key. I need to know employee number, telephone, and email in order to uniquely identify every row. So here is the start point and the end point. This is what the original table looked like on the left-hand side. And you can see in the original table, the nice thing was I could identify every row by just the employee number. However, these repeating groups here are a headache. If an employee gets a third email address, I would have to restructure the table, add a separate column. If I want to hunt for an email address, I need to hunt through 2 or 3 columns. So it's a bit of a headache, okay? So to get rid of repeating groups, we created this new table in which every time there's a repetition, I just create a new record, all right? But the price I paid for that is I now have a composite primary key. Employee number plus telephone plus email, those 3 attributes together constitute a composite primary key. That has its own complications, but that's the price I paid for getting rid of repeating groups. Okay. So let's look at the third example here. An employee could be assigned to multiple projects, and as a result of removing the repeating groups, this is the structure that we had come up with. Okay, so we have all the attributes for project, and every time an employee is assigned to another project, we just add a new record. So whenever there is a repetition of project, we just add a new record corresponding to that repetition. But the price we paid for that is that the primary key now is no longer employee number, it is the combination of employee number and project number. Okay, so look at it, just if you just look at the values, if I tell you employee number 103, okay, then I'm not uniquely identifying a row. I have employee number 103 here, I have employee number 103 here. So just knowing the employee number will not allow me to uniquely identify a row. All right. Similarly, if I know just the project number, I cannot uniquely identify a row. So here's project 15, here is project 15. So it doesn't uniquely identify a row. However, if I know employee number and project number together, that's the composite primary key, then I can uniquely identify any row. So if I tell you employee 101 and project P64, then there is only one row that corresponds to that combination. Okay. So notice that this structure doesn't allow for, in real world situation, employees get pulled off projects and then they get reassigned to project. It doesn't allow for reassignment. This structure assumes that once an employee is assigned to a project, they stay with that project. Okay. So if reassignments are possible, then you would need to design a different kind of table. But I hope you're seeing the trade-offs. So we fixed the repeating value, repeating group problem with the transition, with the redesign that we did by adding new rows for each repetition. But in the process, we are complicating the primary key. So here is the start point and the end point. So on the left-hand side, you can see the original table, which has the repeating groups. So every employee could be assigned to multiple projects. In this case, the table has been designed so maximum of 2 projects. But we had a discussion about why the repeating groups are a problem. I won't repeat that discussion. To fix the repeating group problem, what do? I take this project, these 3 attributes which constitute the project, and every time there's a repetition of that value, so by repetition of the value we mean a second project being assigned to employee, we just add another record. Okay, so Michael Smith, when they're assigned to P15 and P64, those are the 2 projects to which Michael Smith is assigned. I just have 2 records for those 2 projects. All right, and we fixed the repeating group problem. Now, if I want to find out information about any the hours worked on a project, on different projects, then I just have to look at one column. If I want to work on the names of projects, I just have to look at one column. So there are a lot of simplification that has occurred. However, the price I've paid for this getting rid of the repeating group is that the primary key has now become composite. I need to know both the employee number as well as the project number in order to uniquely identify any row. So I hope you got a sense of uh, what repeating groups mean, why they arise, and when they do arise, how to, in a table, if repeating groups show up in a table, how to fix that in order to get the table to be in first normal form. So putting a table in first normal form is the starting point of the normalization process. It's like preparing the patient for treatment. Okay. Okay, so this slide just summarizes what I just said a minute ago. We just had a discussion of what we mean by repeating groups, and try to think of other practical examples where repeating groups arise. There are many different instances where these things appear in real life. That's why we have to deal with them in a database. If they didn't arise in real life, there would be no need to deal with them. Okay? So with repeating groups, you have to think about what are the data quality and data integrity issues that arise with repeating groups. We had a discussion of that at the beginning of this lecture. And then we went through a process of discussing how to handle repeating groups and the complication that it introduces as a result of that. So once you start with a table that's in basic relational form, that is the column names are unique and so forth. Look for repeating groups, get rid of repeating groups, and identify the primary key. At the end of those steps, the table that you have is in first normal form. And that is the starting point of our treatment of trying to get the table to what's called a well-formed state. That is treating the patient to get it to a healthy state. Okay, so that's what we will look at in subsequent in the next presentation. That is how to start from a table that's in first normal form, inspect it, and then if we find deficiency, if we find anomaly, how do we get to higher and higher normal forms, give stronger and stronger medicine to heal the patient, basically to get the table to a form where those anomalies are no longer present.